Okay, welcome back. I've put together a very simple model so we can analyze the data that was entered into the data warehouse. So this is a tool called Tableau. And if you remember what the model looked like earlier, there's an intersection that is intersection consists of a crossing street and an intersecting street. So this looks a little bit like the anchor model. I'm using the latest view here, connecting these through the tie to the street latest view. So let's look at what this looks like in the worksheet. I created a very rudimentary analysis where I've plotted all the streets that are crossing streets and all the intersecting streets like this. And there's a small square for each intersection where something's happened. There's been a collision. So this is just the collision count, and the little square is colored. So if there have been many collisions, you have up to number 10 here, which is 10 collisions, and if there's been just few collisions, it's green. So if I point at, for example, this small red square, we can see that, well, East 57 and Park, pretty unsafe crossing according to the data that we had in these from these 4 months. Whereas this one, very light green, it's Bowering Canal, it's safer, it's 5. And if we take one that's dark green, for example, that one, which is Riverside and Broadway, it's just one collision at that place. So this is the data that we loaded. And it also shows you how it's easy to connect to the anchor model directly from Tableau and actually do some analysis. So if you look at the raw data that we have, not raw, the data that we have in the data warehouse that we saw in Tableau, this is what it looks like if you look at the intersection, and we saw this before. It contains the measures that we looked at. We looked at the collision count, this one. You can see that there was one collision, and this one will then have references in the tie to the different streets where that collision happened. But as you can see, we also have metadata here that connects back to the metadata structure. And in the metadata structure, we can actually follow the lineage of the data. How did this data enter into the data warehouse? So we'll look at that and see what that looks like. The metadata model, you can pick which database you want it to live in, but in our case we picked the staging area. So here you have the metadata schema, and in the metadata schema you will find all the metadata tables. So let us look at the metadata model quickly. First, when you run the SQL files that are generated from the Sisula framework and you execute them in SQL Server, it will actually store the actual configuration also in SQL Server in this configuration anchor with the corresponding attributes here. So if we move back to SQL Server and look at the configuration, there it is, and select the rows. Oh, sorry, I should have taken the latest view of this one instead. For those of you who are not familiar with anchor modeling, the latest view is joining an anchor with its attributes. So it looks like a third normal form table. So here we have the following workflow. The following configuration name, which is the workflow, and then we have vehicle and traffic. Here are the actual XML files. What type of file it is. This is a workflow, this is a source definition, this is a target definition. So if I click, for example, the source definition here, you can see that this looks exactly like the file here. This is the source definition file. But this is a file on the file system, so when I executed this SQL file that was generated from this, this one is also appended and inserted into the database. You see all the terms, they're actually on one line here. Okay, so let's go back. So you have the configurations here, and you can also see then which jobs that have been created came from which configuration. Same thing with works. So let me explain this. A job corresponds to an SQL Server agent job. So in the database, a job is what you find down here. So we have two different jobs. We have a staging job and a loading job. So those are the jobs. But a job may contain one or more units of work. And the units of work correspond to job steps in the SQL Server agent. And if you look at the attributes here, you can actually see that when you run the framework, it will actually also store the actual agent job ID. So you can use these internal system tables in SQL Server if you want to do further tracking. So this ID is what you would use then to find the data that SQL Server has stored about that specific job, or the specific step that was run by the agent, if you look at the work unit. So the unit of work would correspond to the different steps within this job. So there would be 7 different steps in this one. And those units of work, they may also work on different objects. Or since we're talking ETL and data, we look at these as generalized containers. So this unit of work may involve a source and a target container, in this case. What they do is that when it works on the source and the target, it may also perform different operations. And in that case, there would be some number of deletes, updates, and inserts being made. So for example, if you read a file, there would be a file container here. And you see the type is down here, container type of file, and there will be a file container and a target, which is a table container. So it's loading data from the source, the file, into the target table with some number of operations. Probably then it would be a number of inserts being done. So this is a simple metadata model, and this is what the framework uses to store information when it runs. So let us look at Tableau again, because I also hooked up Tableau against the metadata. And we will look at the jobs that we ran earlier. So I'm going to switch to presentation mode here. So here you can see I've sorted the jobs after when they were started. So the first or the latest job that was run was actually the, I don't know why that stuck. The latest job was actually the vehicle loading job, and you can see here these are the different steps that this job did. So it ran this one, then it ran this stored procedure, then it ran this stored procedure, and finally it ran actually this stored procedure. And here you can also see which containers this particular stored procedure worked with, or unit of work. So this one worked on the table called vehicle collision typed. So it took data from this table and inserted it into this table, the intersection table. The whole thing took 10 seconds and it performed 4,902. Oh, I think this is the whole job actually, and not the actual steps. This is actually the duration of the job. But anyway, it inserted 4,902 rows when it performed this. So you can track stuff, and down here you will actually have the staging job. So this was the latest staging job we did. And in this one you can see the bulk insert. It actually worked on 4 different containers. It worked on the May, June, July, and August files that we had, and it inserted all of them into this view, insert view here, which made it end up in the raw table. And that whole thing took 8 seconds. And you can see here what it did, how many rows came from each file respectively. Now we had a little bug on the key, so there was a lot of duplicates. That's why we don't have the sum of these rows being inserted over here. Oh, by the way, there could be less intersections anyway, of course. So you have very good capabilities for actually tracking and seeing what is going on when you're running your ETL process, provided that you hook up some sort of analytical tool. It could be Excel also, of course. So let's move back here. So like I said, if you look at the data over here, no, not that one, in this one, you can see there are some metadata identities here. And these were inserted when the data was loaded into the data warehouse. And you can select whatever reasonable identity you want to put in the metadata. It could be the job ID, it could be the work ID, it could be the container ID. In this case, I actually used the container ID, so this 11 here corresponds to the container from which this row was loaded. Still though, if I have the container, I can always track back and see how this was loaded. So if I select from this one, and we will see what identity 11 is. And you can see that 11 here is 2014-06, so it's from June. So going back, the 11 here, this data came from the June file. So that was a little bit about the type of metadata you can see, and well, we also saw a little bit about what the data looked like when it entered the data warehouse. But let us look closer again at the files. So the one we've been looking closer at so far is the source definition, which defines the structure of the staging table. But we didn't look that much at the target definition. So let us look at the target definition. The target defines the sort of the source to target mapping. Actually, it is columns that you find in the staging area tables, and those are mapped to columns that you find in the latest view in the data warehouse. So here, for example, you can see the mapping directive, which says that map this source column to this target column and the type of mapping that you have. So there are some different types of mappings, and what the mapping, if the mapping is specified as a natural key, there will be a join on this when you do the insert into the data warehouse. And the reason for doing that join is that if it provides the information that is necessary for the framework to deduce if this is something that has been seen before or if this is something new. So in the case that you are trying to insert a street name that it has already seen before here, the natural key here will tell the framework to do a join on this, do a lookup and see, is this street new, or is it something that was known before? If it's something that was known before, now there aren't that many attributes here, but if it had been a lot of different attributes that were not part of a key, then those attributes would be updated if they're changed, and you have history on those. If not, if it's a new one, then of course new data will be inserted. You can also do some pre-processing and post-processing before this actual mapping and loading is done. So if you need for some reason to do pre-processing, you can do it in this before section here. And after the before section, you can actually also do some processing. This one will be entered as a sub or a derived table into the actual loading process. So we're going to look at what exactly the SQL looks like that's generated from this one. And you can also do some post-processing if you need to. So in this case, these selects are actually doing the necessary aggregations that we want to do before actually then inserting this. So in this case, when it says source and the column name of the source, it would be the column name that you have in your derived table here. And it continues like this with a lot of different mappings. So let us look at the generated SQL. I'm actually going to run this generation again for instruction purposes. As you remember, it's the run all that will generate the SQL from the XML files. So now we'll have a new target SQL here. So this will create a number of stored procedures, and these stored procedures will later on be called by the SQL Server job agent as different job steps. So looking at this one, the first one will create the stored procedure that will load the streets from the collision data. And these are all, to begin with, automatically generated things that have to do with the metadata that makes sure that it logs when the work was starting, if it was a source to target mapping within this one, etc. So down here you have, if you have preparations, they would have appeared here, but we didn't have that for this step. So here you have the merge into the latest view. And using, this is what I call the derived table. So if you look at the target XML, let's see, it was the street we were looking at. Was the first one? Yeah. So looking here, you can see that this corresponds to the SQL code that I wrote here. And you don't have to write anything. If I don't write anything, it will just use this source table, and you can reference those columns directly. So it's only if you need to do some sort of processing on this or extra transformations, which is quite common, that you have this derived table. And as you can see here, there's a join clause, and the join clause is defined by what you specify as being a natural key here in the mapping. So in this case, you can see when it's not matched, it's going to do an insert, because then we know it's a new street that we haven't seen before. Probably this one didn't have any historized. If it had historized attributes, I'm just going to check to make sure. No, I don't have the model available right now, but if it had historized data, then there would be a when matched statement as well, where it would actually do an update of the data. So, and here you can see that it also outputs some information, this merge statement, and this is just to count the number of inserts, updates, and deletes that are that is performed by the statement. And then some more logging stuff, and of course it's all wrapped in try-catch to actually capture also the errors if they happen and store the error messages in the metadata as well. So let's see. let's look at, I'm going to show you one, I think, where we have, lost the formatting. Okay, here we have one. This is the final one that actually inserts information about the number of collisions, vehicles injured and killed at different intersections. So it also has a key here that is doing the join on, and it has this when matched also. So in this case, when it's not matched, it's doing this insert, and like I said before, if it's matched, then it's going to do something else. So in this case, if it is a match and there is a difference between any of these columns, so it's going to actually check and see if any of these are actual changes, then it's going to do the updates, where it actually updates all of these values and performs that. So as you can see, there's quite a lot of SQL code being generated from this not so large XML code. The same thing goes for the source. If you remember, the source definition is not that long, but if you look at the source SQL and all the different stored procedures that are being created, you can see that there's quite a few here as well that are being created. So finally, we also have the workflow. The workflow XML is what defines your job steps in the SQL Server agent. So here, most of these, this is probably a file that you wouldn't touch that often. As with the other files, you can work with both environmental variables, but also your own defined variables. So here I define a variable which is called stage, and another one which is called path. That is consists of the expansion of another variable and data. Some variables here, so I can in clear text, or at least in readable form, decide what will happen when a job ends in different situations. Should it quit with success, quit with failure, go to the next step, or go to the step with some identity? So looking at this, you can see that you have a number of different, you can have jobs, and jobs can have job steps. So here we have a job called create raw table. It works in the stage database. It is a TSQL job, and on success action is go to the next step. And the job actually does very little. It just executes a stored procedure with some parameters. These are parameters that are necessary to track what the SQL Server agent is doing. So these are defined earlier as a variable here. So these variables will be passed to all of the stored procedures. Then it creates an insert view, which is also just an execution of a stored procedure. However, the bulk insert works a little differently. So rather than being a TSQL job, this is a PowerShell job. And this is PowerShell code here that you can find here. So in this case, the bulk insert will actually do some PowerShell to find the files in a specific folder that you've specified. And once it's found the files, then it's going to invoke and run a stored procedure with the file name as one of the arguments. So this one is a little bit different that way. And the rest are just TSQL jobs, and they all execute stored procedures. So here you're actually free to, if you need other job steps than the ones that we have here, For example, if you need to do some specific transformation and you put that into your own stored procedure, you can have your own job steps defined here, and they will be picked up the next time you run, and you get your workflow SQL, and when you run that in the database, your jobs will be entered into the bigger picture in the workflow and be taken care of the next time you run the job in the SQL Server agent. And the loading is also very similar to the staging jobs. It's execution of a number of stored procedures in this case. There are a few other parameters. For example, the extra options here is something that is used within the bulk insert job step. So I can remove this recurse, then it won't recurse into the subfolders that you've specified in this path. But if I keep it, it's going to recurse and look for jobs further down. And you also have a file name pattern you can specify over here, which is also used by this one through variable substitution. So this is again a regular expression that it uses to find matching file names. So file names needs to start with 5 digits, followed by collisions and ending with a CSV. I don't know if we showed you this, but this is what the SQL code looks like for the creation of the jobs in SQL Server Agent. So as you can see here, for example, it's going to create a job step, and this job step has a name, step ID, subsystem. So basically what you find here as being sent into this stored procedure that creates jobs, all of these parameters are actually corresponding exactly to the attributes that you define over here. So if I say subsystem TSQL, it's going to be converted into subsystem TSQL over here. So if you know that there are some other parameters that you want to send into your job, you just have to look at what parameters can this stored procedure take as input, and you can use that and enter that in your workflow XML file as well. So I think we're going to stop with this video, and in the next video we're going to be looking a little bit closer at the Sisula engine to understand how this XML actually is turned into the SQL. So I'll see you in the next video.